Okay, simplify x to the 9 divided by x to the power of 2. Well, I know that when I divide, I subtract the indices, so the answer is x to the 7. Right, this expression is a single power of 7. Okay, so my numerator is x is 7 to the power of 8 times 7 to the power of 4, which is 7 to the power of 12. And then I'm going to have 7 to the power of 12, which I'll have to divide by 7 to the power of 3, which gives me 7 to the power of 9. Question 2. Change 32.4 cubic meters into cubic centimeters. Well, how many cubic centimeters are in a cubic meter? Answer 1,000,000. So I'm going to have to do 32.4 times by 1,000,000, which is going to give me 324 with 5 zeros on the end. They are a very mathematical explanation for question 2. Okay, we've got to show that the sum of these two mixed numbers is 8 and 7/15. So I'm going to start with the two mixed numbers. I'm going to add them together and trust that I'll get 8 and 7/15. So add the wholes together. Right, I've got thirds and fifths, so I'll turn them both into 15ths. 2/3 is 10/15. 4/5 is 12/15, so I get 7 and 22/15, which is indeed 8 and 7/15. So there we go, 8 and 7/15. That's number 3 done. Right, number 4. The diagram shows a triangle. Yes, it does. Now, what do I know about triangles? Angles add to 180. Let's have a look. Work out the value of x. Right, so I know that the angles in a triangle add to 180. So that's going to be 30 plus 4x plus 10 plus x plus 20. Altogether, that has to add to 180. So that means, if I tidy up the left-hand side here, that 5x plus 60 equals 180. Well, take off 60 from both sides, gives me 5x equals 120. Divide both sides by 5, x must be 24. There we go, so x equals 24. Okay, question 5. We have to construct a bisector of this angle. So what I'm going to do is I'm going to open my compass up. It doesn't matter how far, just don't change it once you've opened it. So I'm going to open it up about this far, and then I'm going to stick it in at the point A, draw an arc and draw an arc. And now, again, no need to change your compass setting. I'm going to carefully put the point in at that point and then put the point in here and draw that arc. Ruler pencil. Okay, line it up carefully. There's no point in losing marks through not being accurate. Draw your line right through that point, and there you go. There is the bisector of angle BAC with all my construction lines shown. Okay, question 6. A bag contains only red beads, blue beads, green beads, and yellow beads. The table gives the probability that when a bead is taken at random from the bag, the bead will be blue or the bead will be yellow. Good, okay. The probability that the bead will be green, all right, is twice the probability that the bead will be red. So this number here, the probability that the bead is green, has to be twice the probability that the bead is red. Sophia takes a random bead from the bag. She writes down the colour of the bead and puts it back into the bag. She does this 180 times. Work out an estimate for the number of times she takes a red bead from the bag. Well, first of all, I think we need to work out what these missing probabilities are. So I know that blue and yellow together add up to 0.55, which means that red and green must be 0.45. Now I know that the probability of it being red has to be half of the probability of it being green, right? So that means that I'm going to have to split this into 0.15 and 0.30. Split it into thirds, really. Now, the probability that the bead is green is twice the probability that it's red. So there we go. Probability that's green is twice the probability that it's red. So if she draws out a bead 180 times, how many times do we expect her to get a red bead? Well, it's going to happen 0.15 of the time, and she's going to do it 180 times. So that tells me the number of times I would expect her to draw out a red bead. All right, which gives me 27. Okay, question 7. Solve the inequality. Well, I solve this very similar to an equation. I'm going to take 7 off both sides, which is going to give me 2x is greater than minus 3. Divide both sides by 2, which gives me x is greater than minus 1.5. X is greater than minus 1.5. All right, solve the equation here, showing your algebraic working. Let's have a look. Well, I reckon x squared minus 3x minus 40 equals 0. I'm going to try and factorize the left-hand side. I know it has to multiply to a negative number. So that means that one of my brackets will have a minus in the middle and the other one a plus. Now it has to multiply to minus 40. 2 and 20, 5 and 8, 4 and 10, and it has to add up to minus 3. So it's actually going to be minus 8 and plus 5. Okay, so x minus 8 times x plus 5 equals 0, so therefore x equals 8 or minus 5. 8 or minus 5. Okay, question 8. The table shows the cost in euros of Bridget's car insurance in each of the years 2016, 2017, 2018. Yes, it does. Bridget says the percentage increase in the cost of my car insurance from 17 to 18 is more than the percentage increase from 16 to 17. Is Bridget correct? Right, well, let's first of all find the percentage increase in her car insurance from 17 to 18, 2017 to 2018. Right, well, it went from 545 up to 592. So the increase is 47 euros. Now, find the percentage increase. I put the change over the original and times by 100. So 47 divided by 545 equals times by 100. Gives me a percentage increase of 8.6238 and so on %. Right, the second thing we need to do is the percentage increase in the cost of car insurance from 16 to 17, 2016 to 2017. Well, it went from 500 up to 545. So it was an increase of 45 euros. Percentage increase, 45, the change, over the original, times by 100. 45 divided by 500 equals, times by 100 equals 9% increase. So we know which is greater, but now we must check on whether Bridget's got them the right way around. She says the percentage increase from 17 to 18, that's this number, is more than that number? Well, she's wrong, isn't she? And the question is Bridget correct? So the answer is no, she is not correct. Henry wants to insure his car. He gets a discount of 15% off the normal price. And now we know what he pays after the discount. Work out the discount that Henry gets. So this is going to be a reverse percentage, isn't it? If we knew what it was before, then going forwards, we would be knocking off 15%. So to reduce something by 15%, we multiply it by 0.85. So if we were going forwards, then we would be multiplying by 0.85. So to go backwards, we have to divide by 0.85. 952 divided by 0.85 means that the original price was 1120. Okay, now let's be careful. What's the question asking us? It's saying work out the discount that he gets. So the discount is the price he should have paid minus the price he paid, which gives me a discount of 168 euros. Okay, number 9. The density of gold is 19.3 grams per cubic centimetre. That means that every cubic centimetre of gold weighs 19.3. Look at this. We've got a volume of 150 cubic centimetres. How much would that weigh? Well, if 1 gram weighs 19.3, if 1 cubic centimetre measures 19.3, then 150 cubic centimetres measures 150 times 19.3. So sticking that into my calculator, I get the answer 2,895 grams. Number 10, change a speed of 50 meters per second to a speed of kilometers per hour. Well, if it goes 50 meters per second, it goes 60 times as far in a minute, and 60 times as far again in an hour. So that's how many meters this speed is per hour. 50 times 60 times 60. So that is 180,000 meters in an hour, and we want it in kilometers per hour. So simply divide that by 1,000. The speed is 180 kilometers per hour. So that's question 9 and question 10. Okay, number 11. The diagram shows a shaded shape, A, B, C, D, made from a semicircle and a right-angled triangle. AC is the diameter of the semicircle. Work out the perimeter of the shaded shape. Give your answer correct to 3 significant figures, right? So, the perimeter of the shape, the length around the edge of the shape. Well, if I start from D, I know that's 17, so that's easy. I'm going to have to work out this curved length here, and then that's 15, back to D. So really, I'm just going to work out the curved length. The curved length is half a circumference, isn't it? I know the circumference of a circle is pi d. So it'd be really nice if I knew the diameter of the circle, which I can find by using Pythagoras, of course. So let's just have a look. Let's call this d for diameter, shall we? Right, so 17 squared equals d squared plus 15 squared using Pythagoras. Or you might prefer just to say that the diameter is the square root of 17 squared minus 15 squared. Well, that diameter is the square root of 64, so the diameter is 8. Okay, good. So I know the diameter of the circle is 8 now, which means I can work out the circumference of the circle. In fact, I'll just work out the length of AC, the length of that semicircle. So that's going to be the circumference of the circle, pi times 8, divided by 2. Okay, so what's the whole of my perimeter? Well, it's going to be, the perimeter is going to be 17 plus pi times 8 divided by 2 plus 15. That's the length of my 3 lengths added up. So I can simply work that out now on my calculator. So I've got my answer, which is something like this: 44.56637. Now I'm asked to give the answer to 3 significant figures. So my answer to 3 significant figures is 44.6. 44.6. Okay, question 12. Astrid wants to buy some oil. She can buy the oil from either Dane Oil or Arctic Oil. Here is information about the price that each company will charge. Right, Dane Oil will sell her this many litres. Oh, by the way, how many litres is that? That is 4.2 times 10 to the 5, isn't it? Which is 420,000 litres. For that many krone, okay. And Arctic Oil, they're charging dollars, typical, right? So let's have a look. How many litres will they sell? 8.6 times 10 to the 5. 1, 2, 3, 4, 5. There we go. They'll sell that many litres for $770,000. Okay. Astrid wants to get the better value for money. Oh, there's an exchange rate provided. Good. From which company should she buy her oil? Dane Oil or Arctic Oil? Right. Well, let's start off with Dane Oil. And let's work out how much they charge per litre. So, Dane Oil will give her this many litres, 420,000 litres, for 2.5 million krone. So, 1 litre is 2.5 million krone. There we go. Divided by 420,000. Right, let's have a look. 2.5 million divided by 420,000 gives her a price of 952,380 krone per litre. Now, let's have a look at Arctic Oil. Now, I'm going to draw a line down my page. Right, Arctic Oil. Okay, Arctic Oil will give her 860,000 litres for $770,000. So, 1 litre must be 770,000 divided by 860,000. So, stick that in my calculator. 770,000 divided by 860,000. That gives me a price of 0.89 and so on. I'll keep the number in my calculator. That is dollars, isn't it? Per litre. I need to change that into krone so I can compare it. Now I know the exchange rate. $1 is 6.57 krone. So to change this into krone, I'm simply going to multiply my number of dollars, which is on my screen, by 6.57. So that is 5.882 krone per litre. So it's a very narrow thing, isn't it? It seems to me that Arctic Oil is cheaper than Dane Oil. So to answer the question, where should she buy her oil from? She should buy from Arctic Oil. There we go. That is question 12. Question 13. A, B, C, and D are points on a circle. Yes, they are. There's the centre. AOD is a diameter. Yes, it is. Well, already, given a diameter, I know that this angle is 90 because it's 90 degrees in a semicircle, isn't it? So that might be useful. Right, okay. Angle C would be CBD is 28. Oh, already I know that that one's 28 because angles in the same segment are equal. BDA is 32. Oh, look at that. So this one is 32 because angles in the same segment are easy. Right, let's have a look at the question now, shall we? Find the size of angle BDC. BDC. Aha, I think I've already done that because I think that this is a triangle and I know 28 and I know this one is 90 plus 32, so I can work out the third one. Right, okay, so let's set out our reasoning because it does say give a reason for each stage of your working. Right, so the first thing I'm going to do is I'm going to say that ACD equals 90 degree in a triangle in semicircle. Okay, there we go. Right, now I'm going to say that this angle BCA is 32 because angles in the same segment are equal. BCA equals 32. Angles in same segment are equal. And now I believe I've done enough to find the angle which they wanted. Where's it gone? Which is angle BDC. Let's have a look. BDC, here we go, that one. So BCD, CD equals 180 minus 90 and 32 is 122 minus 28. And that is 180 minus 122 minus 28 gives me an answer of 30 degrees. And my last reason is 180 degrees in a triangle. 30 degrees. So that is the end of question 13. Okay, question 14. There are 20 glasses in a cupboard. 13 are large, 7 are small. Roberta takes at random 2 glasses, so there's no replacement. Complete the probability tree diagram. Right, okay, so the probability of the first one being large is 13 out of 20, and of the first one being small is 7 out of 20. Fine. Now, if the first one's large, then there'll be 12 large ones left out of 19, and there will still be 7 small out of the 19. Now, if the first one's small, then instead of 7 out of 20, the probability of the second one being small will be 6/19, and you will still have 13 of the large ones left out of the 19. So there's the diagram complete. Work out the probability that Roberta takes 2 small glasses. Well, that's the probability of ending up here at small. So it's going to be 7/20 multiplied by 6/19. So I'll just do that on my calculator. 7/20 times 6/19 gives me my answer of 21/190. Okay, here are 6 graphs. Question 15. Yes, there are. Complete the table below with the letter of the graph that could represent each equation. Write your answers on the dotted lines. Right. So the first one I'm looking for is y equals 2 over x squared. Right, well, I know that as x gets large, x squared gets really large, so 2 over x squared will get really small. So I'm going to be looking for something that as x gets larger here, 2 over x squared gets much smaller, so it's going to look like that on the left-hand side. Now, when x is negative, x squared is positive. So in fact, that's going to be exactly the same here. So the answer is C for that one. Okay, let's look at the next one. Y equals a half minus a half x cubed. Y equals minus a half x cubed. Well, I know not what y equals x cubed looks like. Y equals x cubed looks like this. When x is really large, x cubed gets really, really large. So it looks a bit like that. And then when x is negative, x cubed is negative. So it's kind of like that. Now, this is y equals minus a half x cubed. So forget about the half because the scale isn't really shown, but y equals minus x cubed. That would mean that each of those would be reflected. So I'm looking for something that looks like the red. So I'm thinking it's going to be B. Okay, right. Next one. Y equals minus 5 over x. Right, let's do this in red here. Y equals minus 5 over x. Well, I might as well have a think about y equals 1 over x first. Now, y equals 1 over x. It's going to look like this. When x is 1, then I get the answer 1. When x is a half, so it looks like that, because this is 1 over a million, isn't it? And then when x is negative, it's going to be exactly the same, only negative. So that is y equals 1 over x. So given that there are no scales, that might as well also be y equals 5 over x. Now if y equals minus that, it's going to be that green line and that green line. So I'm hoping I can find one that looks like that, and I can. It's E. So there you go. C, B, E. Question 16. Make x the subject of this expression here. Okay. So we're going to start by squaring both sides, which will give me y squared equals x over 1, x plus 1 over x minus 4. Multiply both sides by x minus 4 gives me y squared x minus 4 equals x plus 1. Multiply out that bracket gives me x y squared minus 4y squared equals x plus 1. Now I need to make x the subject, so I'm going to put everything with an x in it on one side of the equation, so a minus x from both sides, and everything without an x on it on the other side, so I'm going to plus 4y squared to both sides. Right, factorise the left-hand side. X lots of y squared minus 1 equals 1 plus 4y squared. Divide both sides by y squared minus 1. And there you are. X is the subject. Okay, number 17. Prove that the difference between two consecutive square numbers is always odd. Right. So we need to explore the difference between two consecutive square numbers. Well, one of our square numbers can be x squared. So the next square number would be x plus 1 squared, which, by the way, is x squared plus 2x plus 1. We've got to look at the difference between our two consecutive square numbers. So that's the larger one. Subtract the smaller one, and that gives me 2x minus 1. Well, 2x minus 1 is always odd, isn't it? Because 2x is always even. 2x equals even implies 2x minus 1 is odd. There you go. So that is question 17. Question 18. Okay, the histogram. Right, so I'm going to be dealing with areas and frequency densities here. It gives information about the times in minutes. Yes, it does. That some customers spent in the supermarket. Okay, I can see that some spent between 0 and 10 minutes and so on. Work out an estimate for the proportion of these customers who spent between 17 and 35 minutes at the supermarket. Right, I'm going to start off by working out the area of each of these bars. And to make life easier, I'm going to use the scale that is on the axis. So this first block here is going to be 10 times 0.7, which is going to be 7. Second block is 5 times 3.4, which is 17. Third block is 5, 6, 7, 8, 9 times 1, which is 9. Right, this one is 6 by 2.5. 6 times 2.5, which is 15. Okay, and this last block is 10, 15 wide. 15 times 4.8. 15 times 4.8, which is 72. So if I add up my entire area there, okay, then I get 120. So whole area equals 120. Okay, now I need the proportion of these customers who spent between 17 and 35 minutes. So let's just make this really clear, shall we? 17. Right. Here we go. That's from here, isn't it? 17. Right, and 35 minutes. 35, that's this long. So now I need to know the area between the red lines, don't I? Right, well, if I have a look at this first rectangle here, that's now 3, 7 times 1. Well, that's 7. This second area is still 15. Now the third area is going to be 5 times 4.8. 5 times 4.8, which is 24. So now I've got 7, 15, and 24. 7, 15, and 24. Where's the question gone? Question 18, I'm on. Here we go. Come on. Here it is. 7, 15, and 24. Right. 7 plus 15 plus 24. That's 22, 42, 46. So the proportion of people is 46 out of 120. Okay, which presumably we should cancel down to give us 23/60. Okay, all right. One of the customers is selected at random. Okay. Given that the customer had spent more than 30 minutes in the supermarket, well, I wonder how many customers or what area is more than 30 minutes. Let's have a look, shall we? More than 30 minutes. Aha! I've lost the question again. Here we are. More than 30 minutes. That means it's one of these ones, doesn't it? It's one of those 72, right? So given that it's one of those 72 customers, okay, so it's going to be out of 72. How many of those spent more than 36 minutes in the supermarket? Let's have a look. 36 minutes. I need a different colour here. I'll do it in black. Right. 36 minutes is from here, isn't it? So it's going to be most of them, isn't it? Let's have a look. It is 1, 2, 3, 4, 9. 9 times 48. Okay. So 9 times 4.8 over 72. 9 times 4.8 is 43.2. So it's 43.2 over 72. I don't like that very much. I think I'll multiply top and bottom by 10 to give me 432 over 720. And then I think I'll cancel that down, but obviously I can use my calculator to do that for me. Gives me 3/5. So that is my answer to question 18. Question 19. Write down the equation of a line that is parallel to the line with that equation. Right, well, the line with this equation, y equals 7 minus 4x, has a gradient This line has a gradient of -4. So I need to write down the equation of a line which also has a gradient of -4. So y equals 8 minus 4x would do it, or indeed y equals anything minus 4x. So as long as your answer is y equals anything minus 4x, then you're in the clear. Okay. A line L passes through the points with these coordinates. Right. Well, I could work out the equation of L, could work out its gradient, could work out all sorts of things. Find the equation of a line that's perpendicular to L. Oh, so the gradient of L will be useful, because then I can find the gradient of a line which is perpendicular to L. Find the equation of a line that is perpendicular to L and passes through the point with coordinates -6, 4. Give your answer in this form. Right. Well, let's have a look at the gradient of L, shall we? So the gradient of L. Well, it's rise over run, isn't it? So I'm going to do the rise, which is -2 minus 1, divided by the run, which is 2 minus -3. So the gradient of this line, L, is -3/5. So the gradient of the line I'm interested in is going to be 5/3. And we also know that it passes through the point with these coordinates. So I can use my y minus y1 equals mx minus x1 formula to write down the equation of the line. Y minus 4 equals 5/3. X plus 6 gives me 3y minus 12 equals equals 5 lots of x plus 6, so 5x plus 30. So it wants it in the form everything on the left. So minus 5x plus 3y minus 42 equals 0. And that is question 19. Question 20. The area of a rectangle is 18 square centimetres. The length is √7 plus 1. Also, I could find an expression of the width without using a calculator and showing each stage of your working. Oh, find the width of the rectangle. Give your answer in this form. So let's have a look. Well, the width of the rectangle is going to be the area, 18, divided by the length. Okay, so I'm going to rationalize the denominator. So I'm going to have 18 times √7 minus 1 over √7 plus 1 times my √7 minus 1. That's going to give me 18 √7 minus 18. And then on the bottom, I'm going to have √7 squared, which is 7, minus 1 squared, 7 minus 1 squared, 7 minus 1, which is 6. So that's going to equal 3 √7 minus 3. Now, what form did it want it in? The form a root b plus c. There you are. That would seem to be in the form that they want. So there's my answer. W equals 3 √7 minus 3. That's question 20. Okay, question 21. Right, the diagram shows a sketch of part of a curve with the equation y equals f of x. There's one maximum point. Yes, there is. The coordinates of the maximum. Yes, they are. Write down the coordinates of the maximum point on the curve with the equation. Aha, we're just going to be transforming the curves, aren't we? So, if the curve is now f of x plus 4, that means that the curve moves 4 places to the left. And so the maximum now won't be 4, 6, it will be 0, 6. All right. What about if y equals f of 2x? Well, if y equals f of 2x, then the x required to give us the maximum was 4. But if we're going to double that, then the x required to give us the maximum will only be 2. So the maximum is now going to be at 2, 6, rather than at 4, 6. Okay. The equation of a curve is that. Okay, the curve is transformed to curve S under the translation 4, 6. So the curve is moved 4 to the right and 6 up. Find the equation of the curve S. Well, if the curve is moved 4 to the right, then we can now substitute x minus 4 in instead of x. So simply with that change, it's going to be x minus 4 substituted in instead of x. So it would be that, but also the curve's moved 6 up, isn't it? So at the end of that, we're going to have to add on 6. Y will be 6 higher for every value of x. Now it says we don't need to simplify the equation, so I suppose we could leave it like that. I'd be inclined at least to leave it like that. But that would be fine. And that is the full solution to question 20. Question 22. The line with this equation intersects the curve with that equation at the points A and B. Find the coordinates of A and B. Right. So I've got two equations, and I'm going to solve them algebraically. So I'll write down the two equations while I think about what I'm going to do. Okay. Now I see the first equation gives me an expression for y. So I'm going to substitute that into the second equation. So the second equation is x squared plus y squared. So I'll substitute that in, minus 2y. And that equals 24. Right, let's see what happens here. So x plus 2 squared is x squared plus 4x plus 4 minus 2 times x minus 2 times 2 is minus 4 equals 24. This is going to be a quadratic, I think. So I'll simplify the left-hand side. 2x squared plus 4x minus 2x is plus 2x. Plus 4 minus 4 is 0. And now minus 24 from both sides. There we are. I've set it equal to 0. I'll divide both sides by 2. Okay. Now, can I factorize that? Yes, I can. We're going to have x and x. We're going to have a plus and a minus. It's going to be plus 4 and minus 3. So x equals minus 4 or 3. Okay. Now I've got an expression for y right here, look. So if x equals minus 4, then y is minus 4 plus 2, which is minus 2. So that gives me the coordinates of A, minus 4 minus 2. And if x equals 3, then y will be x plus 2, 3 plus 2, which is 5. So the coordinates of B must be 3, 5. And that, apart from writing the coordinates where they want them, is the end of question 22. There you go. Okay, question 23. Right, ABC is a triangle. Yes, it is. M is the midpoint of BC, okay, and P is a point here. It tells me AB, it tells me AC, and it tells me AP as well. Okay. Now I've got to find the ratio AP to PM. Well, I already know AP, but it would be useful to know what the vector PM was, wouldn't it? So let's have a look at the vector PM. Now the vector PM, if I'm going from P to M, well, I think I'm going to go from P back to A. So that's going to be minus AP. Right, so I've gone from P to A. Then I think I'm going to go up to B. So plus AB, because I know what that is. That's 4A. Now I'm going to go down to M. Well, down to M, that would be a half plus a half of B to C. Now I don't know BC, but I bet I can work it out. Let's work out BC, shall we? So if I want to work out BC, I'm going to go from B to A. That's be minus 4A, and then plus 2B. Okay, and for my PM expression, I'm interested in a half of BC, aren't I? So that's going to be minus 2A plus B. Okay, let's go back to the blue expression, and let's find an expression in terms of a and b for p to m. So it's going to be minus AP. So that's going to be minus 3 over 2A minus 3/4 B plus A to B. Well, that's 4A. Plus a half BC. Well, I already know that that's minus 2A plus B. Right, so if I simplify this, and I'll have PM in terms of A and B. Let's have a look. So I've got minus 1.5 A's plus 4 A's minus 2 A's. So that's going to leave me with minus a half A. Now the B's. I've got minus 3/4 plus a B. So that's going to leave me with plus a quarter B. So I've got PM in terms of A and B. And obviously I've already got AP now. So if I'm going to find the ratio AP to PM, then I'm going to find the magnitude of AP. Right, the magnitude of AP is going to be the square root of 3 over 2 squared plus 3/4 squared. Okay, so on my calculator, that gives me 3 root 5 over 4. And I'm also going to find the magnitude of PM. That's going to be the square root of a half squared plus a quarter squared, which gives me, on my calculator, root 5 over 4. Now the question asks me for the ratio of AP to PM. Here we go. AP to PM. So that is 3 root 5 over 4 to root 5 over 4, which equals, I can multiply both by 4, can't I? 3 root 5 to root 5, divide both by root 5, gives me 3 to 1. So my ratio is 3 to 1. And that is the end of question 23. Okay, question 24. Express this expression here. I see I've got two fractions. I've got a subtraction here and then a division. I'm going to have to keep flip change, aren't I, there? Or keep change flip, rather, as a single fraction in its simplest form. Right. Okay, so I've got, when I'm looking simply at this, I'm going to have 4. I'm going to multiply the first fraction, top and bottom, by 2x minus 3. So I'm going to have 4 lots of 2x minus 3 on the top of there. And on the bottom, I'm going to have 2x minus 5 and 2x minus 3. And then I've got minus. Now the second one, I'm going to multiply top and bottom by 2x minus 5. So I'm going to have 3 lots of 2x minus 5 over 2x minus 5 times 2x minus 3. So I've got the same denominators now on those two. I'll put that in a square bracket so I don't mess it up. I'm going to keep that fraction, keep, change, and now I'm going to flip this one over. So that's going to give me that on the top and 9x minus 4x cubed on the bottom. Right. Okay. In the square bracket then, I have got everything over 2x minus 5, lots of 2x minus 3. And what have I got there? Well, I've got 8x minus 12 minus 6x plus 15, which I'll simplify in a minute. And what have I got going on here? Times. Now, I'm going to factorize the top and bottom here. Factorize the top of that. Right, okay, well, I'm going to try. I know that I'm going to have 2 minus signs. I'm going to try 2x and 3x here. And I know that these have to multiply to 5. So probably, definitely 1 and 5. Okay, so if I try the 1 here, see how many x's I'd end up with, and the 5 here, then that's not going to work. But if I do the 5 here, and the 1 here, have a look at that. I get minus 15x and minus another 2x, that gives me minus 17x. So I factorise the top, now I factorise the bottom. I can take out, can I only take out an x? Perhaps I can. Only take out an x gives me x lots of 9 minus 4 x squared. Oh, wait a minute. Difference of 2 squares on the bottom there. I'll deal with that in a minute. Right, back to the left-hand fraction. I've got 2x plus 3 all over 2x minus 5, lots of 2x minus 3, multiplied by, oh look, there's a 2x minus 5 there. That's going to be useful in a minute for cancelling. 3x minus 1. And on the bottom here, I've got x, difference of 2 squares here, 3 minus 2x, and 3 plus 2x. Right, when I cancel fractions, before I multiply fractions, rather, I look for any cancelling. Let's have a look. I've got 2x minus 5, 2x minus 5. I've got 2x plus 3, and 3 plus 2x. I've got 3x minus 1 here. I can't see anything on the bottom to cancel that with. So I think I'm going to end up with 3x minus 1 all over x lots of 2x minus 3, 3 minus 2x. And that is my answer. Okay, Mario is going to save $50 in the year 2021. Okay, great. He's going to continue to save up to including the year 2070 by increasing the amount he saves each year by $k. Right, so we've got the year 21 when he saves 50. He's going to carry on. So in the year 22, he's going to save 50 plus k. Okay, in the year 23, he's going to save 50 plus 2k. He's going to carry on all the way up and into and including the year 2070. Okay. All right. So this looks like an arithmetic sequence to me. Okay, this is going to be the first term, and this is going to be the 50th term. And each time, the value of the term goes up by k, doesn't it? All right. Mario will save a total of that much in the 50 years. So the total of these 50 terms is going to be $33,125. Well, of course, we've got a formula for the sum of an arithmetic sequence at the top of the formula sheet. The sum of the first n terms is n over 2 multiplied by twice the first term plus n minus 1 times the difference between the two terms. So in this case, the sum of my first 50 terms is going to be 50 over 2 multiplied by twice the first term, twice 50 is 100, plus n minus 1, so that's 49 times the difference of the terms, which is k. And I know that that equals 33,125. So here is an equation for k for me to solve. I'm going to divide both sides by 25, which tells me that 100 plus 49k equals 33,125 divided by 25, which gives me 1,325. Subtract 100 from both sides, so 49k is 1,225. Divide both sides by 49, and k is 25. So the answer to the question is that k is 25. So Mario increases the amount that he saves each year by $25. Okay, 26. Here is the sector of a circle. Okay, I can see the sector of the circle. This is obviously the radius of that circle, isn't it? Okay, and I've got an angle x. Right, the sector can form the curved surface of a cone. Okay. The height of the cone is 25. Okay, the volume of the cone is 1,600 cubic centimeters. I'm going to work out the value of x. Right. Well, to start with, looking at this cone here, if I know the volume of the cone, then that will surely help me. Let's have a look. Now, my formula for the volume of a cone is that the volume is a third pi r squared h. And I know that the volume of this cone is 1600. So 1600 equals a third pi, I don't know r, but I do know h. Right, so I can solve this equation, multiply both sides by 3, divide both sides by pi and by 25, will give me an r squared of 61.11, and so r is 7.8176. Now I'm just going to write down loads of decimal places because I know I've got to give my answer to the nearest whole number. Okay, so that's the radius then. So this radius here is 7.8 and so on. Good. Right, now it would probably help me if I could find the area of the curved face of that cone, because then I'd know the area of this sector of the circle, and then I could work out x. Brilliant. Right, so mission, find the area of the curved surface of the cone. Well, I've got a formula for that. So the area of the curved surface of the cone, area of the curved surface, is pi r l, where L is the sloped height. So L is this height. Right, so I better find that height, hadn't I? Well, I can do that using Pythagoras. So let's just find L first. L is going to be the square root of 7.8, etc. squared plus 25 squared. Remembering to square root it, of course. So L ends up being the square root of 686 point ... and so L ends up being 26.193. Right, so now I know L, I can surely now find the area of the curved surface of this cone. Right, so the area is going to be pi times 7.8 and so on times 26.193 and so on, which gives me an area for that curved surface of, let me just stick that into my calculator, 643.29 and so on and so forth. So that is the area of the curved surface. So the area of this sector then, here, so the area of the sector is 643.29. Good. Right, now I need to know what fraction 643 is of the area of the whole of this circle. So I need to be able to work out the area of the whole of that circle. Well, this radius here is 26.193 ... So I can work out the area of that whole circle. Right. So the area of the whole circle will be pi times 26.193 squared, which is near enough, well, it's 2,155 with lots of decimal places. So what is that angle x going to be? Well, it's going to be 643.23 over 2,155 times 360, which gives me an angle to the nearest whole number of 107 degrees. So that is the solution for question 26, which was really just a canter through all the formulas given to us at the front of the paper. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.